Good morning, good afternoon. Welcome to Cisco Unplugged. Hi, my name is Darshan today, and let's talk about iPad Pro experience with our Wi-Fi 6E access points. So before we begin, the first and the most important part that we need to understand is how does our client iPad Pro able to hear beacons and probe response for Wi-Fi 6E. So we have talked previously about it. And this is our iPad Pro is using reduced neighbor report. And to summarize it, what does it do is it uses existing 2.4 and 5 gigahertz BSSIDs that send out at beacons. It utilizes the same beacon to provide the information that, hey, we have Wi-Fi 6E BSSID, and this is the information. So it saves the airtime, which is very crucial, as we all know about Wi-Fi. So the next step is to understand about Wi-Fi 6E requirement. And the most important part is to understand power spectral density and EIRP. Previously, in 5 gigahertz, as we know that every time we double the channel width, we reduce 3 dB. And in order to overcome that with 6 gigahertz, as we know, frequency is inversely proportional to wavelength, that increasing power and increasing the channel width will increase it with the 3 dB more per channel width. So in fact, it will help with the more channel width. And the question that we all have it, how should we design it or one-on-one replacement? We will have a new session to describe about 6 gigahertz design criteria. But overall, as long as you have it between 1.2 to 2K, like 2,000 square feet, you should be all good with one-on-one replacement from your 2700, 3700, or 3800, 2800 to 6E access point like 9136 or 66. So now coming back to what is going to be your maximum EIRP of transmission power. As we can see in the FCC, with 20 megahertz, 40 megahertz, and 80 megahertz, which is at 80, it is 24 dBm. And for that, as we know, the client is going to have 6 dB less. So the maximum client transmission power is going to be 24 dBm. And 80 megahertz, as we talked before, it is more likely that it's practical to use it. So we will come back over here, and before that, let's talk about a real-world experience about the configuration of WLAN that under this testing, what we have done for iPad Pro. So for configuration, we have created one WLAN for our testing purpose, and that is going to be just a PSK SSID. And that PSK SSID, we have WPA2, WPA3, and .1x enabled over here, 6 gigahertz, 5 gigahertz, and 2.4. And under security, we have enabled only WPA3, and fast transition is being disabled over here, while PMF is required. We have both H2EH and HNP enabled. So what configuration on top of that is required for our testing? So a few things we need to remember, that we have used AI RRM over here, an RF profile that is created in DNA Center. But we can talk about that configuration over here by going through it. Under RRM, we have chosen the configuration of, and you can decide. It's always preferred, and we have tested that. For example, if you create or design your 5 gigahertz with 14 dBm, it's better to have 3 dB more to achieve the same coverage for 6 gigahertz. So in our example, we have a minimum power level set at 18 dBm. And dynamic channel assignment, which is being best, it is recommended to have 80 megahertz as a channel width. While in 5 gigahertz, you can make changes over here with dynamic channel assignment of 40 megahertz and 20 megahertz. That's how we tested it out. So let's understand our test results. So if 6 gigahertz has been configured with 80 megahertz channel width and 5 gigahertz on 20 megahertz and 2.4 on 20 megahertz, iPad Pro has always preferred 6 gigahertz. If 6 gigahertz is 80 megahertz channel width and 5 gigahertz is on 40 megahertz, that is a typo over there, it still prefers iPad Pro at 6 gigahertz. And the last one is if 6 gigahertz is on 20 megahertz and 5 gigahertz is on 20 or 40, it still prefers, iPad Pro prefers not the first time, but the second time it will prefer 5 gigahertz. And one important setting that we need to remember before we go is here. Configuration under WLAN is you need to have a client steering for 6 gigahertz to be configured. And that will help you. This 6 gigahertz client steering is recommended and you should use it. So it will prefer 6 gigahertz over anyone else. Okay, thank you.